Continue. Worksheet 9D. And here we want to find out the x. What is the location of this? In order to find out the areas, what is x here? So there are a few ways that we mentioned earlier. The slope equal to the magnitude. The slope of the shear curve equal to the magnitude of the distributed load, -4, as you can see. So you start from this point, +5, and go down to this point is 0, and the slope is 4 kips per foot. So as you can see from that, the x, by that, it have to be x equal to 5 kips, 5, start from the 5 kips from the left, divide by the slope equal to -4. As you can see, if we just get the magnitude, 4 kips per foot. From that, we can have x equal to 1.25 feet. Everyone see that there? So here, this x is 1.25 feet. So from there, we can have that equal to 1.25 feet. The other way that you can find out, so get the magnitude from the left, and you can see divide by the slope. So you will get the x, where the shear at that point from the left to that point equal to 0. Okay, the shear there is 0. Or the other way that you use is the similar triangles. So we can have if x that defined at that point, so you can have that here, it will be equal to 4 feet minus x. So with similar triangles, what I have is x over 4 minus x is equal to 5 on the left, divide by 11. Here we just only get the magnitude, and 11 kips, as you can see there. From that, we also have the x equal to 1.25 feet. So basically use your geometry. And from that one, as you can see this, and it equal to 4. So x is 1.25. So you have 4 minus 1.25. You will get it 2.75 meter, no, feet. 2.5 feet in there. Okay, so from that we can now go ahead to find out the areas for these triangles. 5 times 1.25 divided by 2, because that triangles. So the areas here that you can find out is equal to plus 3.125 kips, and these areas equal to 1/2 of 11 times 2.75, it equal to -15.125 negative, and that is kips. So we can find out the area. So now, as you can see, very important, see what is the location that make a zero shear in that point. Use either way that you have. Okay, so I could write down here is or the other ways to find out x, or the other way, you can see that. So let's circle down here so that you know, review with your geometry. So let's move to the shear diagram. Done. And now moment diagram, we already prepare everything. Just go ahead to complete. Always start from left and 0. So we start here 0. Nothing for the couple at the first 2 feet. So we have -20. So go down -20. We're 20 here. -20. So the chain. -20. And then you have a 10 foot kips couple apply at B and it clockwise, so it causes the discontinuity, and in this case clockwise, so it move up, so 20 move to 10, move to 10 here. That's what you have, so it's negative 10 at that point. And continue between B and C, you have negative 20. That is the change in the moment equal to the area under the shear curve. So negative 20, so 10, negative 20, negative 10, another negative 20, so it becomes 30, negative 30. So 28, 30 here, negative 30. And no distributed load, nothing, the shear constant, so it will be straight line, negative 30. Now CD, there are no couple at C, so no worry about the discontinuity. Area here is 12 plus 15 equal to 27 positive, so that is 27 positive. So we have negative 30 plus 27, so it will be 3, negative 3 there, negative 3. Negative 3, because that negative 30 you plus 27, 12 plus 15, 27. Now the bottom line is, what is the direction it should go? What is the direction, I mean, what is the curve look like? Whether it's just go that way, or whether it go the other way. Because parabolic, right? A cube, sorry, because the parabolic for the shear, then the moment is cubic. Which way? Which way or not? Go back to see the shear. And you can see the shear from CE plus 11 and at D plus 5. And the shear equal to the slope of the moment diagram. So on the left, as you can see 11 going down to 5. So it will be bigger slope at the C compared to D, so it have to be go the blue one, go to blue one. Okay, and then continue for between D and E, we have 15, so negative 3 plus 15, so we have 12, so 12 it will be there, 12. And there is no distributed load, the shear is uniform, so it will be straight line, and go to plus 12 to have the change is between those two plus 15. And the next one, and very important, because that's why we define where is the X location, and it equal to 1.25, and you can see there 1.25. So the change again between point E to 1.25 feet, then it increase another 3.125, so 12 plus 3.125, it equal to 15.125. so the area there 16, so it 15.125, and as you can see the shear is from 5 to 0, so it have to be curved that way to make it 0 at that point. And then the next one, it have a negative 15.125 from the middle point to F. So as you can see, parabolic 15.25, negative 15.25, so go back to 0, so you will have it here. And make it 0 there, and good, it finished at 0, it means we do it correctly. So that is the moment diagram, and put back here we have straight line, and this is cube, keep that in mind, cube, and then this is straight line, and this is parabolic, and this is parabolic that you can see. So from that we can find out, okay, the maximum moment in this beam equal to negative 20 foot kips, and the maximum positive moment equal to plus 15.125, and the maximum shear in this beam is equal to negative 11 or plus 11 kips. So that make sure you master and understand all of this problem, because it's become very important, and whatever concept you apply here, it will be similar to other problems.